Here is question number 26. 27 similar mercury drops are falling through water with terminal velocity 4 cm per second. If the drops combine to form a single drop, then the terminal velocity of this bigger drop in water will be what? So the question belongs to terminal velocity. Now, first of all, let us calculate the radius of the formed bigger drop. We know that volume is going to be constant. It means the bigger radius volume must be equal to 27 times volume of smaller drops. Now 4 by 3 pi times capital R cube, where capital R is the radius of bigger drop, equals 27 times into 4 by 3 pi small r cube, where small r is the radius of smaller drop. 4 by 3 pi cancel. Here we have got the radius of bigger drop will be 3 times the radius of smaller drop. Now we know very well that the expression for terminal velocity Vt will be given by 2 by 9 times r square divided by coefficient of viscosity neta in bracket rho minus sigma times g, where rho is the density of object, sigma is the density of liquid, neta coefficient of viscosity, g acceleration due to gravity, we know very well. Now here the liquid is not changing as well as the drops are not changing. The material is same, so we can say that rho gonna be same, sigma going to be same, g is same. Coefficient of viscosity depends upon the liquid, which is water here, so that is also same. So we can say that the terminal velocity is depending upon r square directly. Now if the radius becomes 3 times r, then the terminal velocity, suppose Vt dash, will be what? 3 times r whole square. So we can say that taking the ratios, we get Vt upon Vt dash equals r square upon 9 times r square, which equates 1 by 9. So from here we can say that Vt dash will be what? 9 times previous terminal velocity, that is 9 into 4, 36 centimeter per second. So new terminal velocity Vt dash will be 36 centimeter per second. New terminal velocity will be 36 centimeter per second. Now let us proceed to the next question, that is question number 27. Here is question number 27. Weight of solid is 250 gram in air, 50 gram in an unknown liquid, and 150 gram in water. The relative density of solid and unknown liquid will be what? Suppose the density of solid is rho s and density of unknown liquid is rho l. Now apparent weights are given. Let us consider the first case, that is the case of liquid. W apparent will be actual weight minus of buoyant force. Apparent weight is given for the case of liquid one, that is 50 gram. Here it is in gram mass. Multiply with g, you will get weight. W actual 250 gram is actual weight, multiply by g, minus of what will be buoyant force? Buoyant force is given by volume of object inside the liquid multiplied by density of liquid multiplied by gravity g. So here g will be cancelled out and we get 50 equals 250 minus of volume of object may be given as mass of object divided by density of object, that is rho s, we have already assumed, multiplied by density of liquid. So from here we will get the ratio for density of liquid with solid as 200 upon 250, which is 4 by 5. Equation number 1. Now let us consider for water. If the solid is immersed in water, then its apparent weight becomes 150. Now putting the apparent weight, we get 150 into g, where g is gravity, equals actual weight, that is 250 into g, minus of buoyant force, which is volume of object, that is mass upon density of object, multiplied by density of liquid. Here liquid is water, whose density in CGS system is given by 1 multiplied by G. G will be cancel out, and after solving we will get the value of density of solid in CGS system, that is 250 divided by 100, that is 5 by 2 gram per centimeter cube. Now plugging the value of density of solid in equation 1, we can get the density of liquid rho L, and that will be 4 by 5 times density of solid, that is 4 by 5 multiplied by 5 by 2. Therefore the density of liquid we will get 2 gram per centimeter cube. Now we know very well that the relative density of object will be same as its actual density if we are talking in terms of CGS system. So that's why the relative density will be, for liquid it is 2 and for solid it is 5 by 2. So therefore relative densities will be 5 by 2 for solid and 2 for liquid. So that's why after looking at the options we can say that option number 2 is absolutely correct. So we'll go with option number 2. Question number 28. A sample of 0.5 gram of water at 100 degrees centigrade and 1 atm pressure requires 270 calorie heat energy to convert to steam at 100 degrees centigrade. If at the same pressure, volume and steam produced is 835 centimeter cube, then what will be the change in internal energy of the sample? We have to calculate the change in internal energy of the sample, and we know very well, according to first law of thermodynamics, if we apply the first law of thermodynamics, the question will be done in a very simple way. So according to first law of thermodynamics, we have total amount of heat supplied will be given by work done plus change in internal energy. We know very well, therefore change in internal energy delta U will be given by amount of heat supplied minus of work done. Amount of heat supplied, here it is given 270 calorie, but we have to calculate the answer in joule, SI system. So you have to convert it, 270 multiplied by 4.2. Now it becomes the heat in joule, minus of work done will be given by pressure multiplied by change in volume, P delta V. So 270 into 4.2, we will get 1134 minus of pressure is 1 atmosphere, that is 10 to the power 5 Pascal. We can write what will be the change in volume. Final, that is 835.5 centimeter cube minus initial. What is the initial volume of sample? Mass is 0.5 gram. Density of water we know 1 in CGS. So we can write 0.5 divided by 1. This is in centimeter cube. But we have to talk in SI system, so we need to make them convert in meter cube. That's why we have to multiply with 10 to the power minus 6. Now after solving, we will get the net change in internal energy as 1050.5 joule. So after looking the answer, we can say that we have to go with option number 1. So option number 1 will be absolutely correct. Let us proceed to the next question, that is question number 29. Here is question number 29. The velocity time graph of an object of mass 2 kg is shown in figure. While it is moving on a rough horizontal surface, the coefficient of friction between object and the surface will be what? We have to take G equals 10 meter per second square. Here from the graph we can say that the speed of the graph is linearly decreasing. So we can say that the friction force is decreasing the speed, or it can act as retarding force. Net force is acting friction, that is F kinetic, given by total force equals mass into acceleration. Fk is given by mu mg. We know very well, m into a. So from here we can get that acceleration will be mu times g, or you can say retardation of the block will be mu times g, and we know very well that the slope of speed or velocity time graph gives the acceleration. Since slope of velocity time graph gives acceleration, therefore we can write slope of VT graph will be mu times g. Therefore mu we can write mu equals slope of VT graph divided by g. Slope you can easily calculate, perpendicular upon base, that is 80 by 16. Gravity we have to take 10, already given in the question. So after solving we will get the value of mu as 0.5. So after looking at the options we can say that we have to go with option number 4, which is absolutely correct. Now let us proceed to the next question. Here is our question number 30. 4 forces are acting on a body as shown in figure. The magnitude of resultant of the forces will be what? Now we have to calculate the resultant force. After looking at the diagram, we can say that 50 Newton and 40 Newton, they are exactly opposite. 37, this goes 53. It means the angles are equal, so they are exactly opposite. We can redraw the diagram something like this. So 40 and 50, they are opposite, so the net force due to 40 and 50 will be 10 Newton, and it will be toward the force which one is larger. So 50 is larger, 50 minus 40, 10 Newton, making an angle 37 degree. Again 20 and 30, they are exactly opposite, so that's why the resultant will be toward the greater one, that is 30 Newton, toward the 30 Newton. So the net force of 20 and 30, they are opposite, will be 10 Newton, making same angle 37 degree. Now the net resultant of them will be what? Their y component will cancel each other. 10 sine 37, 10 sine 37 will cancel each other. You will get the net force F as 2 into 10 cos 37 degree. So 2 multiplied by 10 multiplied by cos 37 gets you 4 by 5. So 2 2 ja 4, 4 ja 16 Newton. Therefore we can say that the net force will be 16 Newton, and after looking at the options we can say that option number 1 is absolutely correct. We'll go with option number 1. Now let us proceed to the next question, that is question number 31.